Hello, I'm Neeraj. Today I will explain the concept of LLM unlearning, but I will suggest you to go through my previous tutorial on machine unlearning. Otherwise, it will be tough for you to understand the entire concept. So these days we require LLM unlearning. So now the question is like why we need LLM unlearning. Actually, what happens when we train the large language model? We need a huge amount of corpus, and several times by mistake or by due to any reason the model uses data which contains some legal compliances, maybe sensitive data, maybe copyrighted data, maybe highly restricted data. And if we leave the model as it is without doing anything, then definitely we will lose that sensitive information, because in any task model will keep that information to the end user. What we can do now, there are two options. First, retrain the entire model from scratch, which is too tough. Second is do some LLM unlearning, means just remove that part of information from the LLM which are sensitive without reducing the efficiency and quality of the large language model. So this is possible. There are a lot of ways we can achieve this. One of the ways to use the parameter efficient fine tuning process. For that we need two type of things. We need a clearly defined data set what we need to forget, and second is like a retention data set, because if we remove some part of the information, because what happens, large language model sees the entire world like a next token prediction. So if we remove some part of the information, it will damage a lot of sequential informations in the model. So we have to maintain the structure of the knowledge while removing the forgetting part. So that's why we need two types of data at the same time. So first of all, we will prepare two different data sets. First is the data set related to the tokens we want to forget, and the second data set is data set with the token informations or other informations that we want to maintain. So let us start. So we take the mini batch data set for which we want to forget the tokens. We apply the forward pass to that large language model, and then we compute the negative log likelihood from the data and for the tokens. This is required so that we can use the exact, we can get the exact probabilistic score for learning process where we have to calculate the gradients. Now for the forgetting part, we will just reverse the objective on the forget data, because in the current scenario you can easily see that if we maintain this current negative log likelihood, then it will add in learning those parts, means the data that you want to forget, it will not forget, it will just learn, because the probability score will be high. So in that case we just reverse the objective, so that if the probability score is 0.9, then it will be like a 0.1. so this kind of reverse will help in forgetting those information. Now at the same time start with data where we want to retain the information, forward pass to the same LLM, and then compute the retain loss. That retain loss, here we will not do the reverse, because retain loss, if retain loss is high, means we want to maintain that part, so we will not reverse this. Now we have to combine the objectives. At the same time, if we forget something, suppose we forget something, we retain something, but we are not maintaining the integrity of the model, then maybe model will deviate from what it is at the early stage. So to maintain the stability of the model, we will again calculate, because we are calculating two different probability distributions, so we have to check that. Here you can see that p theta 0 and p theta means after unlearning what are the things changed and how far the model is from the initial model. So for that we will calculate the KL divergence, so it will give the probabilistic similarity distances, like how similar the two distributions are even after unlearning. And our task is to maintain the stability of the model also, so the KL divergence would be good enough here. Now we will combine all three objectives. So first objective is to learn, means retain what is there in the model. Second objective is to forget what are unnecessary things in the model. Third objective is to maintain the stability of the model. So this is our total stability, total objective. Now we will, after this objective, we will apply the back propagations like we do in the parameter efficient fine tuning process, like LoRa, DORA, QLoRa, anything you can apply. So to know all those things in more detail, you can watch my previous tutorials related to those topics. And after that, we will do calculate the gradient with respect to that enable parameter. We will apply the optimizer steps, and then we will get the model, updated model, where the forget probability will be pushed down and retain utility will be pushed up. And that's why the model will work like it will not memorize the part we wanted to remove, and it will retain the structure of the language model. So here you can see the broader picture, like how the system is working. In the next tutorial I will show the complete working code, so that you can understand that how actually such type of models are working. So here you can say that you have a base LLM model with actual weight frozen. So if you go through the LoRa tutorial, you can easily understand those parts. And after that, insert the LoRa adapters. We can take the B and A matrix. This is the criteria to select those matrix, and then only on those adapter parameters phi we are applying those learn or unlearn things, not for the entire large language models. Be careful on this. And after that we apply the back propagations, and then we will update our model or fine tune our model. So here our fine tuning will depend upon three different objectives. So when you apply the LoRa, your fine tuning depends upon only one thing, but here fine tuning will depend upon three combined objectives. So this is the difference from the traditional LoRa and LoRa with LLM unlearn. But here we apply some set of some sequence of checks also, so that we can say that after learning, after unlearn, the model is not behaving like it was made for. So for example, it will check that inference on the forget parameter prompt, inference on the retain prompts, robustness test, and again it should fail to reproduce the target copyrighted content. So this check should be passed. And the second is like inference on retain prompt. It should preserve the fluency and knowledge, etc., that is required. And third is robustness test. Must test against the correlated prompts, mixed prompts, jailbreaks, etc. Like if the forget success, if the retain utility, suppose it collapses, then it is a sign of catastrophic forgetting. If the forgotten content reappears, then it is like superficial. You have to repeat the process again, or you have to change the parameter, you have to update the parameter. to retrain the model. So this is the complete LLM unlearning process. So in the next tutorial, I will post the code, and I will show some more latest technology for LLM unlearn. So thanks for watching.